That was only because I was listening to music and just hammering Pringles chips.
Oh. Always necessary.
Mm-hmm.
Oh, you're gonna keep hammering.
Oh, for free?
Yeah, well, they've been open. I ate a couple.
Oh.
You're like, oh.
Wait, what flavor?
But you can share the rest. Maybe Fungus wants to crumble some up in his steak.
I'll try for one bite, see how it tastes.
Oh, it'd be really good. A little cheesy crunch in there. Like a rum.
Cute, but you're making me fat joke.
Done. Okay. All right, so 3-2 is polynomial inequalities in one variable. So with this is going to be now instead of just having so this is 3.2. Instead of like what we were doing yesterday was you'd have a problem. Okay, x plus 4 is greater than 7. And there's a is like this, and then x is greater than 3 up and circle to the right. So that would be, it is a polynomial, technically a polynomial equation, but it's a simple polynomial equation. It's just linear, if you will. Today we're going to branch out into what happens when you have like a quadratic type equation, and then specifically with that, looking at where these equations are on like an xy plane, not necessarily shading or anything like that, but thinking about rather just where that polynomial equation is positive or negative, but not actually dealing with the shading part. So when we do an example like this, let's do, we're going to say solve, and number 1, and the first one I want to do is x plus 7 times x plus 9, and that is going to be greater than 0. So this is polynomial because if you FOIL it together, right, you're going to have an x squared, a quadratic type equation. What we are curious about is where is our left-hand side going to be greater than 0? And when anything is greater than 0, it means we have positive values. So we're really curious, what values of x can I plug in and get out positive values? So you say, well, okay, I could plug in, if I plug in 0, well, yeah, if you plug in 0 and 0, you're going to get out 63, which is positive. We're not worried about that at 63. We're worried about if it's positive or negative. So when we think about that, what we know is that on either side of the origin on a number line, like this, on either side of the origin, you'll have a positive and then you'll have a negative, right? Also, when you graph something like this, or graph an equation, whatever, it'll make it look like this. This is a quartic. But here, here, and here, yes, it's not at the origin, if you will. It's not like the number line where this is 0, this is 0. What this is these are zeros of a function here, 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 and here. And on either side of this 0, you'll either have positive outputs or negative outputs. Or you would have, in this case, negative, and then you would have positive. On either side, it's going to be this idea of positive and negative, like that. Where your y values, your outputs, are going to be either positive or they're going to be negative. And so the zeros is what dictate where we're going to have positive and negatives on either side of it. Now you can have, if you have a root like that, this would be called a, what kind of root is that? A double root, yeah, double root. In a double root, it would maintain, in this case, it would go positive, hit, and then stay as positive. And then it would change to a negative. So what we are curious about is analyzing our roots in this case, our zeros. So we would say in this case our two roots are -9 and -7. Now we know that because it's not equal to, it's going to be open circle at both those. Now this doesn't actually say solve and graph, it just says solve. but a graph of this will help us analyze what values work for it. So you just start at the zeros, which is nice because it's already factored, so here's our 2 zeros. And then on either side of that, we want to figure out positive or negative. So we start with like a -10 over here and plug in and just see what we get back out. And if we go -10, then we know we get out a positive because it would be a negative and a negative. So it'll be a positive. And we fully expect this one to be negative.
Yes.
And then what would we fully expect this one to be? Positive. Because what we're actually doing is, like this, if we were to graph, if you forget the like greater than or equal, greater than 0 part, if I said, okay, that is going to be a parabola, because it's a quadratic, that opens up and goes through -7, -9. So what that actually is, right, is -9, -7. It's a parabola that opens up like that through -9 and -7. Those are my 2 zeros.
It's a nice looking parabola.
Oh, please. And we know it opens up
Because A is positive.
because A is positive. So we know we'd be going from a positive to a negative to a positive. But you can, and that's what we have there. But you could also plug in test points to get that as well, which we did, like plug in a -10. We didn't plug in a -8, but a -8 would yield a negative and a positive, therefore it'd be a negative. So our answer in this case is we're only looking for which type of values? Positive values. So in this case, x is less than -9, going that direction, or x is greater than -7. You have to have it's a disjunction in this case. Based off of our graph, it's a disjunction. Okay, so step 1 would be, although it was already done for us, factor, and it factored there. But step 1 would be factor, and then go from there. So let's do this one. If I have 1 minus 2x minus 3x squared, and I want to figure out where is this less than 0. Now you could, like on a graphing calculator, you could graph this and then just see where it is, where your graph ends up being negative, below the x-axis. But the idea that they want us to do is to work on our factoring and then solve from there. So these should be factorable. Now, if you don't like the negative x squared portion, if you're like, I like working with a positive x squared for factoring, that's fine. You can multiply everything by a negative, just make sure to do what with the sign? Switch the sign around. Or we can deal with this with a negative. We can go like this, we can go like this, 1 and 1, and then we're going to have 3 and 1, which is 3x and x.
Minus plus.
And then minus, and then plus. So then we maintain the integrity of the inequality sign. Now here we just have to solve for x. So x for this one would be 1/3, and then x would be -1 there. So that's what our zeros are, our roots. And we are, again, we're looking for where our values are negative. So we know we have a -1 there, and we know we have a 1/3 there. Open circle, because it doesn't equal to. Now, if you think about this parabola, your parabola is opening up, or is your parabola opening down?
Down.
Opening down. So you could just do a quick mental sketch as well. Your parabola is really doing this, right? Opening down through there. Therefore, to the left of -1, your values are all negative. Between -1 and 3, your values are positive, and to the right, your values are negative. And you could confirm that by just plugging in like a -2, and you would see that you get 1 plus 6 times a -1, so you get out a positive times a negative if you plugged in a -2. We're not looking for what the value is, we're just looking for if it's positive or negative. And if you plugged in 0 here, it would be 1 minus 0, 1 plus 0, so you'd have a positive, because it would be a positive times a positive, so that would be positive. So you should see this pretty much alternating order unless you're getting into double root stuff, but you should have an alternating. So our answer is we're looking for where it's less than 0, so we're looking for negatives, right? Anything less than 0 is negative, so we're looking for x is less than -1 or x is greater than 1/3, and that's the answer you're looking for. Again, you don't have to graph them, but you can see, at least maybe you can see, the graphing makes it a little bit easier. Let's do just a couple more here. If I have 2y cubed plus y squared, the y cubed we don't love typically when we're factoring. However, a lot of times they set it up for us to be factorable. So when we have a y cubed, what's the route for factoring that we can go when we have a y cubed? Grouping. Nice. Yeah. 740 right there. Yeah, grouping. So it doesn't always work that way, but a lot of times the problems are set up that way. So we group it. A lot of times we can group it right down the middle. And so we pull out the y squared, be left with 2y plus 1. And then in this case, we'd be pulling out a what? I don't know, 3?
Yeah.
And then that's going to give us a, like,
4y plus
4y minus 3. Like that is less than 0. So we look and we say, okay, did that work out for us?
Nope.
No, it didn't. So we tried at least that grouping. What are the other types of grouping that you could do?
by coefficient. Like, could you move 12, the minus 12y over?
Yeah, so you could say, oh, over here?
No, to pair with the 2y cubed.
Yeah, so we can move it around. Oops, that's minus, right? Minus 12y plus y squared plus 9, right, is less than 0. And then you're saying something like this.
Yeah.
And then you look at that, and you would have, you pull out the 2y, and you're left with y squared minus 6 plus y squared plus 9. Does that flow well?
No.
No. So, is this one factorable with our methods? No. There is some sort of factoring method with cubics that can be done. We just don't, I don't teach it. It's just not, I don't see any need for it. It's one of those that it's not, I don't see any need for it. In which case, if you couldn't factor, if I said solve this, and you're like, again, what we're looking for, going back over these two that we've done, I am looking for the what of that polynomial. I'm looking for the intercepts, right? I'm looking for the roots. So I'm looking for the roots. So if this has roots, which it does, because they set it up so that it could be factorable, except we don't learn this type of cubic factoring, so we're not going to factor it. If it is factorable, then the roots should be rational. So you could do rational root theorem, which we remember we disregarded that. So then what's our other option, right?
Graphing calc.
Graphing calculator. So the expectation here would be, hey, use the graphing calculator, find the potentially three intercepts, and then figure out where it's positive or negative. So if this type of one was on the test, I would probably say solve with a graphing calculator. If one like this is on the test, it's like solve with graphing, show your sine graph like we just did there to come up with your solution. But one like this, we would say, hey, let's use the calculator in this case. So questions on that? We don't need to solve it out now. I just wanted to give this one as like, okay, yeah, grouping, nope. Oh yeah, grouping, nope. Okay, something's off here. So I won't give you like one that's really challenging where you're going to spend a bunch of time trying to group it and give some direction to that. But did you find them?
I find intersection.
Yeah, so it should have intercepts though. It should be rational intercepts on that. Okay, let's do this one, because this one causes, or not causes, it gives us a fraction. So how do we deal with that? X minus 5, X minus 6. So in this case, we've been talking about, hey, we're just looking for the factors, or excuse me, yeah, factors, the zeros, the roots, the solutions. In this case, though, with the fraction, we're not only looking for the zeros, because the zeros would be found by looking at our numerator or denominator. If I said find the zeros of this, zeros mean what do you plug in that makes it equal to 0. So if I'm looking for the zeros, I'd only be looking at the numerator. In a case like this, when we're working with the polynomial inequality, we're again just looking for where are you getting positive and negative, and those are going to be based off of our roots, like we have here, like we had over there, which you do with the graphing calculator here. It's also based off of domain restrictions. Domain restrictions as well would be here and here. So in other words, what we would have is we would include all of these in our mix of ones to consider what happens between them. So like this, like this, like this, like this. So just find all factors, numerator and denominator, and include those in the mix. So then when we go to plug in values, if you plug in 0, let's say, what do you get when you plug in 0? You end up with a positive or a negative.
Positive.
Should be a positive. Yep, negative, 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 negative by plugging in 0 for there. And then if you plug in 3.5, that's going to be positive, and then negatives across the board, so negative. And then we're expecting it to alternate, but we plug in 4.5. Now we're getting positive, positive, negative, negative, so positive. And then you plug in 5.5, you get positive, 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 negative, negative, and then you get a positive. And in this case, which values am I looking for?
Less than 0.
Less than 0, so I'm looking for the negatives, right? So x is greater than 3, less than 4, or x is greater than 5 and less than 6. And I'm looking for the negative portions on that. Let's do one. Okay, yeah, let's talk about this. If I have solved the graphing calculator, what I would want to do in this case, this you're looking for the roots just by looking for where it crosses. But these ones, they're not expecting you to factor it all. Although they could, I guess, be factorable, but they're not, they just say solve the graphing calculator. So what we would do is, if we have x cubed plus 2x squared minus 3x minus 6 is greater than 0. If they say solve this with a graphing calculator, then the expectation would be is that you would graph this. Okay, so you pull out your graphing calculator and you would graph the. Now, when you go to graph the x cubed portion, we're not actually worried. When you graph the greater than 0, we're not actually worried about that part. We will just go x cubed. And then plus 2x squared minus 3x minus 6. and then you're going to graph that. So what all we're doing is we're going to graph it, and then we get this picture. So like on your test, if you had this on your test, you would go, okay, I'm looking at this, and it goes here, there, and then comes up there, and like this. It looks about like that. I don't know if yours is looking like that. Okay. So that's not solving it, that's just graphing it. What we want to do is we want to find all the values for x that make this inequality positive or negative.
Positive.
Positive. So in other words, we're looking for positive y values, positive outputs. All my positive y values appear to occur where? From here going up, right? Now this appears to be a double root. Now I don't know that for sure, but if you zoom in on it, we might be able to see, or it's not what?
A double root.
It's not a double root. So you can also, what Preston has analyzed, and as I do a little trace of the function, I see that I pop above the x-axis slightly and then come back down, right? So what I see is that my picture here, there actually it goes above slightly and then comes down. So there's actually this window right there that's also going to be positive, along with from here on up that's going to be positive. So I need to find out what my intercepts are, and it'll be x is greater than something, x is less than something, and then or x is greater than whatever value that is. And you do that just by calculating your intercepts. So does anybody have them calculated? Anybody? What's one of our intercepts? Somebody's going to have one of them by now. I think somebody should have one. Maybe not.
-2.
-2, okay. I'll buy that. So this one's -2. All right. What's our other one going to be?
-1.73.
-1.73.
Yeah.
Okay. And then the other one should be positive 1.73 because it's just the square root of 2.
What's the square root of 17 again?
So yeah, there it is. That's how you would solve it, is you look at your and find the zeros and then go from there. So the other thing is you'll have is it'll state use the graphs to solve. Oh, you'll also have some graphs. I don't want to take the time to do it, but if you had a graph like this, I'll write the inequality up there and then we'll talk about it. If you, and then I don't want to take the time to plug it in, but if you had, because if you understand number 5, then you can do this one no problem. Negative x plus 10. If you're struggling on number 5, how to graph and find zeros, then this one would also be an issue, but you can hopefully work through that. So if this was the case, and it said solve using your graphing calculator, meaning graph it and then solve it. There's 2 routes to go about this. One is that you could graph the 2 different inequalities that I have up here. You could graph the left inequality, you could graph the right inequality, and then you'd be looking for where the left one is greater than the right one, meaning where are the y values of the left side greater than the y values of the right side. And I'll do a picture to actually work on a problem like that. The easier thing to do is set it equal to 0 and then just look for positives and negatives. So if I just add the x over, I would have x squared plus 2x subtract the 10 plus 4 is greater than 0. Now I'm back to, I'm going to graph this parabola and then look for where my outputs are positive. So that's all I'd be looking for. Where are my outputs positive? That's the easiest way to do it rather than graphing two different ones and looking for where one's greater than the other, which I'll show us an example of because you have one problem that you have to visually look at something. So in this case though, keep in mind is that if my parabola happens to look like this, let's say, where are my positive values? Everywhere. There's no negative values, right? So every x value you plug in, if you plug an x value in out here, what's the output going to be, positive or negative? Positive. You plug an x value in way out here, what's the output going to be eventually?
Positive.
Yeah, that's going to keep going way up, right? It's going to be positive. So in this case, if the parabola looks like that, then all outputs are positive. So what would your answer be? All reals, yeah. All reals. Every x value works. Okay, last thing I want to show you is you're going to say, hey, you're given to function where is p of x greater than q of x. So if I say where is p of x greater than q of x, and actually let's do this. I'll do q of x in green because they actually have like a black and a red graph or something. So if I have, colors, that's fine. So we'll just make the xy axis in blue. But let's say I have, and I'll try to make these some integral values. Let's say I have p of x goes like this, and comes like this, goes down like this, comes up like this. Okay. I have that, and then let's say I have q of x then, which is in green. Q of x comes and let's say q of x is like this. I'm trying to make our something like that. Okay. Now, if you don't draw this perfect or you're not drawing it all, that's okay. Our values I set out are hopefully integral values, meaning -3, -2, -1, 1, 2, and then up to 3. So in this case, what I would be looking for visually is, where is my blue graph, p of x? Remember in function notation, p of x is the same thing as y. F of x is the same thing as y. So really what I'm asking, where are my y values of the blue graph greater than my green y values, right? Or the y values of the green graph. So I'm just looking at where is the vertical greater on the vertical, where is the blue above the green is all I'm asking. So where is blue above the green? So when I look at this, if I look way over to the left of -3, that's why I made the intersection about it, -3, where they cross each other. Where they cross each other, what do I know about p of x and q of x where they intersect?
Equal.
They're equal, right? So neither one is neither greater than the other, they're equal. But if I look over here, what do I notice about my y value of the green compared to my y value of the blue? If I'm comparing this spot right out here. Is green greater or than blue, or is green less than blue?
Greater.
Green is greater because I'm simply looking at the y value. The y value here is greater than this y value down here. So when I come over here, as soon as they intersect and as I go past blue, like this blue value here is greater than that green value here. The blue value here is greater than the green value here. Blue is greater than green. Blue is greater than green. And all of a sudden, what happens right here? Blue and green are equal, right? The same. So what I recognize is blue is greater than green from, we would state things, I'm looking where is blue greater than green, we would say, okay, where x is greater than -3 and less than 1, -1, I should say, okay? And then you look and you say, okay, then what happens? Well, green goes along here, green is greater, now they're equal. Then if this was the case right here, you just have to estimate and say, I don't know. Let's call it between x is greater than a -1/3 all the way up to +2/3. I'm just making, an estimate of what that looks like there. So I'm saying that's a -1/3 there and a +2/3 right there. Where blue is again above green, then blue goes below green until the very end here, and then what happens? Blue goes above green for indefinitely, so then x is greater than 3 going forward. Make sense a little bit? Yeah, you have one problem that'll look like that. So, and again, if you have to estimate, just estimate, it doesn't have to be exact. Okay?
Question. Can you help me, understand the math stuff I missed?